If you were to be given this integral and just take a look at it, you might think it's very, very, very complicated. It takes a lot of steps and a lot of thought. But what if I were to tell you it's actually not that bad? It's just a simple U-sub. How would we go about it? So if we want to make everything as clear as possible and really write out all of our steps, what we can start off by doing is writing about every single part of this integral. So let's do it one by one. E to the power sine of square root of x. That's one part, right? Now, another part would be cosine. Another part would be, then you have the 1 over 2 square root of x, and then the fourth part would be our dx, right? So now the order that you can choose your u is you can think of the most inside part, and then which of those inside parts is the most ugly. So we can go first, inside, second, ugly, right? So what's the inside part of this one? It's just our sine of square root of x, right? Inside part of this one, square root of x. What about this one? You can say it's x or square root of x. Doesn't really matter. It's, we'll just say that it's just for good measure. And then our dx, there's nothing else here besides our dx, right? And now we can, start figuring things out. Which one of these is uglier? Sine of square root of x, square root of x, square root of x, or dx? Well, it's a pretty easy decision to make, right? Sine of square root of x is clearly much more ugly. This one wins every single time. So since this e to the power sine of square root of x consists the most inside and ugly part of this integral, we say that that is our u. Our u is equal to sine of square root of x. Now, next step, du, right? Take the derivative of sine of square root of x. So remember, this is a chain rule where we're first going to take the derivative of our outside function, sine of x. Derivative of sine is cosine. And now, we have to remember that when we're going to do this, we have to take the derivative of our inside function. The derivative of square root of x is 1 over 2 square root of x. And then always include the dx in here as well, right? And now look, we can kind of write it like this. Divided by 2 square root of x dx. And now here's the really cool part. Our original integral can be expressed as something like this. Our integral of e to the power, just say that divided by 1, right? Times cosine and now look at this. This part right here is replaced by our u. This entire part right here is replaced by our du. Look at that. Everything's replaced. So we can kind of write it down here now, where it's just simply our integral of e to the power u du. Look at that. This mess of an integral becomes something so unbelievably easy, so recognizable just by a simple u substitution, right? Now, taking the integral of e to the power u is easy. The integral of e to the power u is the same thing as if it was e to the power x. The integral of e to the power x is e to the power x. Same thing for e to the power u. Plus some constant c. And now the next step, final step, is that we have to recall what our u was. Remember, our u was equal to sine of square root of x. So our final answer becomes plus c. And now this entire mess of an integral has a very simple antiderivative, e to the power sine of square root of x. That is how you solve this problem.